In our next section, we're going to look at some additional exceptions to the zone-based policy firewall configuration we have on router 3, where again we have three different zones. We have the inside that is on the connection from router 3 to router 4. The connection to BB2 is the DMZ. The connection to router 2 is the outside. Specifically in the policy, for traffic that is going to the DMZ, we're saying that if it is going to this destination address, which is BB2, and it is telnet traffic, we are going to inspect it. For anything else that is not this traffic, we are going to drop it, but also generate a log. This policy to the DMZ policy is then called from two different pairings, the inside to DMZ and the outside to DMZ. The third policy, inside to outside policy, says that devices on the inside can either telnet or send ICMP traffic to the outside. And this is being inspected, which means that it is now allowed back in automatically. So next we're going to look at two additional configurations. The first one is how do we now control traffic that is going to router 3 itself or coming from router 3 itself. Then additionally, what do we do when we have any type of non-standard applications that cannot be matched by an inspection engine? Now again, if we look at the routing design, we have router 3 running two different routing protocols. We have EHRP on the inside, we have OSPF on the DMZ, and on the outside. So if we're going to filter any traffic that is going to router 3 or coming from router 3, the first thing that we need to do is to make an exception for any of the control plane protocols. So I don't want to break my IGP routing or my BGP routing by filtering traffic as it is going to router 3. Now I'm going to configure two different policies here. One that is from the inside to self, which is going to control traffic as it's coming from router 4 going to 3, and a second policy that is from the outside to self and from the DMZ to self, where essentially these are the untrusted networks, the outside and the DMZ, going to the router itself, where I'm going to allow the OSPF traffic there, but I'm not going to allow anything else. From the inside to router 3, I'm going to allow the EHRP traffic. I'm going to allow people to ping router 3, to telnet to router 3, and to SSH to router 3, but no other traffic flows are going to be allowed. So just like any of our previous policies, the first thing that we need to do is categorize what is the traffic that we want to match. And this is going to be accomplished with the class map of type inspect. So on router 3, we're going to have class map that is type inspect. This is going to be the inside to self class, where the inside to self class, remember that these class maps will actually have the match all logic by default. So I'm going to change this so it says class map type inspect match any, so I can use this for any of my exceptions. Okay, specifically in this case, I'm going to match protocol EHRP, match protocol telnet, and ICMP. Now notice here that the application level match doesn't have an entry for EHRP. Some of these are not going to be listed. Like if I were to say match protocol OSPF, match protocol BGP, BGP is available, but EHRP and OSPF are not. So now if I want to classify this traffic, I'm going to need to call an access list as well. So what I'll say here is match access group with the name of inside to self ACL, where IP access list extended inside to self ACL will say permit EHRP any. But since I'm calling the class with the match any logic, if we show run section class map, if it's telnet, if it's ICMP, or if it is whatever's matched on this access list, then it's going to be matched by the particular policy. Now the policy, likewise, policy map type inspect, is now going to be the inside to self policy. For class inside to self class, we don't have the option for inspect when we are dealing with the self zone. If we want to manually allow the traffic in, we have to use the pass action. Now we'll see in a minute when we go to send non-standard applications through the different zones, so from inside to outside or from outside to inside, the pass action is going to work a little bit differently than it is with the self zone. If I am passing traffic from the inside to myself, but if I do not have a zone pairing that goes from the self back to inside, it means the traffic is automatically going to be passed back. Now I cannot inspect the traffic here, I have to pass it. Then lastly, I'm going to create the zone pairing. So we'll say zone pair security is going to be inside to self is the name. This is coming from the source zone inside. The destination zone is myself, which is using the service policy type inspect. That is the inside to self policy. Now again, to make this a little bit clearer, let's say show run section policy map. In the class default of this policy, I'm going to say not only should the traffic be dropped, but I'm going to log it. So now if there's something that is being denied, we should generate a log message. Now on router 3, let's look at the show IP EIGRP neighbors. We see we have an adjacency with router 4. And what I'm going to do is clear the adjacency. We'll say clear IP EIGRP neighbors. Now, if that policy is working, the inspection policy, when I look at the neighbors, I should see that the traffic is allowed back in. And we can see that there's log messages that this traffic is being allowed. These packets were passed. If we show IP route EIGRP, we can see that we do have routes being learned from the inside. So the EIGRP packets are not getting dropped. Now, likewise, if I were to go to 4 and ping router 3 or telnet to router 3, these packets should be allowed. These are being passed. Now, if I were to configure router 3 for SSH access, let's say the IP domain name is ine.com. And we need to generate an RSA key. So crypto key generate RSA. For the general keys, I want to make sure that the size of the key is at least 768, which is going to allow us to enable SSH version 2. So from the inside, if I now SSH to router 3, we'll say SSH with the login of Cisco, which is pre-configured, that username, and I'm SSHing to router 3. 3 should generate a log message saying that this traffic was dropped, because in class default, we found the drop action. But if I were to do the same thing here from the outside, if I were to go to router 2 and say SSH with the login Cisco to the outside interface of router 3, we could see that this traffic is allowed because I did not yet define the outside to self pairing. So for the self zone, as long as the pairing is not manually configured, it means that all of the traffic is going to be allowed. As soon as I configure that pairing that was going from inside to self, it means that anything that I'm not manually matching in the class, so anything that falls down to class default, those flows are going to be dropped. Now, if I did want to permit this, the only thing that I would need to do on router 3 is when we look at the show run section class map, would be to go to the inside to self class and add that protocol, match protocol SSH. So you can see, just based on the modularity of the config, it's much easier to maintain this policy when you compare it to the CBAC, because with the CBAC rules, you need to see how they apply to the interfaces, in which directions, what are the manual access lists that you have doing exceptions to the filter or manual denies to the filter. It can get very complicated when you have 3 or more zones and you're trying to manage this with the content-based access control. But with the zone-based policy firewall, since we have this very strictly defined logic of what is the traffic that is being inspected, and then what is the association of the interfaces, so the inside to outside, or the inside of the DMZ, the outside of the DMZ. Even though the resulting syntax is much larger than using CBAC, the final result is easier to manage, and it's much easier to troubleshoot if you're dropping some sort of flow that you don't want to. Okay, so now let's do this in the reverse direction as well. We're going to have the traffic that is coming from the outside going to myself. Now, before I configure any of the traffic classes, I'm going to skip to the next step, which is to define the policy map, type inspect. We'll call this outside to self policy. That says simply for class-default, drop and log the packets. And the reason that I may want to do this is similar to the examples we saw before with the CBAC or with the reflexive access lists or just the basic access lists, that if I drop all of the traffic and log it, I would then know what are the individual flows that I need to permit later. So depending on what's going on in the rest of the network, where in this case we have OSPF routing coming in on the outside interface, in on the DMZ, then maybe we have some VPN traffic. Let's say router 3 is set up as an easy VPN server. Then we have one of the VPN clients trying to connect to router 3. If this traffic flow is dropped without logging it, then it's going to be a little bit more difficult to troubleshoot to figure out why exactly is this flow not working. So if we say drop log in the class default, it's going to give us a little bit more visibility as to exactly what's going on. So I have the policy map outside to self policy that says for class default, drop the traffic and log it. Now we'll have the zone pair security outside, actually let's just say, that's right, outside to self, that is from source outside to destination self. That's using the service policy type inspect. That is outside to self policy. Okay, additionally, I have the pairing that is from the DMZ to myself. DMZ to myself, and this is going to have the policy that is the DMZ to self policy. It says firewall service policy attachment failed. Policy DMZ to self policy does not exist. Okay, for a minute here, let's say logging console at level 6 and logging buffered at 7. Actually, logging console at 5. Because I want to remove some of these messages from the console. Okay, and we'll clear the log buffer. What that meant here is that when I tried to apply the policy, I didn't actually define it first. So if we show run section policy map, I want the DMZ to self. That's essentially going to do the same thing here. So I'll say this is policy map type inspect DMZ to self. That says drop and log everything. Then under the pairing, I have that policy. Service policy type inspect is DMZ to self policy. Now, if we look at the show log to see the buffer, what we should see is that router 3 is telling us that there were packets being dropped that were going to 224.0.0.5 from the outside, from router 2. And then eventually we'll also see these being dropped from the DMZ, where here this was a BGP pairing that this was dropped. And eventually also we'll see this 224.0.0.5. This is the OSPF control plane. And we can see now, since these flows are being dropped, the OSPF adjacencies are down. If I now look at the routing table, I'll see that those OSPF routes are lost. So again, you technically don't have to do this with the policy map where you say log the traffic under the default class. But just for troubleshooting and for verification, it makes it a little bit easier to see exactly what flows are being denied in the network. So now if I wanted to allow this, I would need to manually match the traffic. We'll say IP access list extended. We have to self ACL. Actually, let's do two different separate ACLs. One is outside to self. That says permit OSPF. One is DMZ to self, where we can see it makes the configuration very modular again, but it's a lot of syntax in order to piece it together. Then I have two different classes. Class map type inspect that says match any outside to self class, which says match access group with the name outside to self ACL. Another class that is DMZ to self class that says match the DMZ to self ACL. And then finally, these classes are going to be called from the inspection policies. So if we show run section policy map, this will be the outside to self policy and the DMZ to self policy. Now, just like the modular quality of service, the order that the classes are called from the policies is significant, where it's going to call it in a top-down fashion, just like the QoS policy. So here I have my DMZ to self policy that says for class DMZ to self class, pass this traffic. Then likewise, the outside to self policy says for class outside to self class. And you'll see if you make an error here, it is case sensitive, so it will tell you if the class does or does not exist. So for this traffic, I want to pass it. What we should see now is that if we look at the show IP OSPF neighbors, that router 3 should be able to reestablish the OSPF adjacencies on both the DMZ and on the outside interfaces. If we look at the show policy map, type inspect for the zone pair sessions, And I could put the specific pairing name there. Like if I were to say zone pair outside to self sessions. I should see eventually that this outside to self class is going to start getting packet hits that is going to pass the traffic. So next, let's turn logging back on and see if these packets are still getting dropped. Let's say logging console 7. We see there's a log here. It says packets were dropped, dropping an unknown layer 4 session from 192.10.9.254 going to 224.0.0.5 on zone pair DMZ to self because class default says there's a drop action. And the same is from, same again, it's still occurring here from DMZ to self. Then likewise from outside to self. So now let's look at the config. I want to know, why is that exception that I tried to configure not actually working? Where I have the outside to self class says to pass the traffic, and the DMZ to self class likewise says to pass the traffic. The outside to self class is calling the outside to self ACL. DMZ to self class is calling the DMZ to self ACL. So let's look at what the access lists say. Show run section access list. We have DMZ to self ACL says to permit OSPF. The same is true with the outside to self. So it looks like that these should be allowed. So let's try this. Let's try shutting down the interfaces. Then when we bring them up, I want to make sure that this is not a problem in the order of operations of the config. So now we can see on router 3 that the OSPF adjacencies are back. Notice that I did reload the configuration. The router, there was nothing else I changed in the configuration. So as a side note here, do not exclude reloading as part of your troubleshooting process. If everything in your configuration looks to be solid, you tried removing the config, put it back, and it's still not working, reload, come back in a couple minutes and see if that made any changes. Sometimes when you're constantly adding and removing features, especially in a lot of these security topics, you can run into problems where the router is simply denying the traffic or the feature's not working. And if you reload, when the router reinitializes the process in the order that it wants, then you may see that it starts being functional. Okay, so if we look at our configuration again here, the exceptions that we made is that now we are inspecting traffic as it is going from the inside to myself, from the outside to myself, and from the DMZ to myself. Where from the inside, router 4 is now allowed to ping the router itself, router 3, the firewall. But if we were to do this from the outside, we would see that these traffic flows are going to be denied. The only thing that is being allowed from the DMZ to the router and from the outside to the router, which is outside to self, DMZ to self, is the OSPF routing control plane. Now, again, if we were terminating VPN sessions on router 3, if we were using it as an easy VPN server, we would need to account for that traffic going from the outside to self. So it would be things like our UDP port 500, which is for our ISACAMP, then either for the ESP or the AH, depending on how we're doing our tunneling. Maybe we're doing transparent tunneling with NAT traversal, which would be our UDP 4500 traffic, or maybe we're doing transparent tunneling over TCP 10,000. But the key is that we would need to take these into account because now those packets are locally destined to the router itself. Then once the router receives the IPsec tunnel and does the decapsulation, then it's going to be treated as transit traffic. But if the tunnel is terminating on the router itself, we would need to take that into account in the outside to self or inside to self policy. Now, the other example I want to show here is what happens if we have any type of non-standard application that we're trying to pass through the inspection engine. Where we saw previously from router 4 on the inside, I said that as traffic goes from the inside to out, we're allowing ICMP and we are allowing Telnet. Let's additionally say that now from router 4, I want to allow traceroute. And we saw the same type of problem when we were dealing with reflexive access list or content-based access control, where with a traceroute, the outbound request is different than the inbound response, where the outbound flows are going to be the UDP echoes, where essentially they are UDP packets going to random high ports, but then the inbound return traffic is going to be either an ICMP time exceeded or a TTL expired, so time exceeded, or the ICMP port unreachable, where the port unreachable is coming from the final destination that we're trying to trace to, and the ICMP time exceeded is coming from the individual hops from the source to the destination. Now, to make this a little bit clearer, exactly what type of flows that we need to allow, what I'm going to do here is when we look at router 3 and we see the inside to outside pairing. Okay, the inside to outside pairing, it says call the policy that is the inside to outside policy. If we show run section inside to outside policy, this says it's going to be, if it's the outside inside to outside class, inspect that, otherwise drop it. So this means when traffic is going the reverse direction, the outside to inside, we're going to look at the CBAC state table. If an entry is there, the packet should be allowed. Now notice that I do not have an outside to inside pairing. If I do not have an outside to inside pairing, it means that all other flows that are not already inspected are going to be dropped. Where we saw this previously, like on router 2, we are not able to ping to devices on the inside. We're not able to ping router 4. But the problem is now, since 3 does not have a specific outside to inside policy, it's not going to generate log messages for these dropped packets. So before going any further, to make it a little bit clearer exactly what we need to manually allow, I'm going to first I'm going to lower the console logging. Let's lower this to 5. And then I'm going to create an explicit outside to inside pairing, where we'll say that for policy map outside to inside policy, says for class dash default, class default drop and log. Okay, next we have the pairing, which is the zone pair security. This is going to be outside to inside pairing, which is then going to call it outside to inside policy. So outside to inside pairing says the source of the traffic is the outside zone, the destination is the inside zone. The service policy type inspect is the outside to inside policy. Says firewall policy attachment failed. Policy outside to inside policy does not exist. Where it is referenced here, but what did I leave out? Should say policy map type inspect. And actually I should have realized that because that's why it didn't take the drop and log option. Where this policy here, this is an MQC policy. For QoS, I need to say this is policy map of type inspect. That says for class-default, drop and log. So now under the outside to inside pairing, policy map type ins, or not policy map, service policy type inspect, outside to inside policy. Okay, now that's attached. Now if I were to turn logging back on, logging console at level 7, and go to someone on the outside, which is router 2 here, and I'm going to ping to router 4, the packet is still going to be denied like it was before. The only difference is that now router 3 is generating a log message for it. Because the outside to inside pairing says for class default, drop the traffic and log it. However, for the other flows that are coming from the inside out and are inspected, these will not be denied by the outside to inside policy. So it's an issue of the order of operations here, where what's happening is that 3 says as packets come in on inside and go out outside, make a copy of these in the state table. Now when packets return and they're going from the outside to inside, before I actually look at the outside to inside pairing, the first thing I'm going to do is check the state table. If the session already exists, allow it in. If the session does not exist, then look at the specific pairing that is going from outside to inside to see, do we have a manual exception or do we have a manual inspection? Where I could inspect traffic as it's going from the outside to in. Because the policy is completely up to me depending on how I'm configuring the pairing and then how I'm configuring the policy map. But the point here is that even though I'm telling router 3 to drop all traffic as it goes from outside to inside, it's going to be those flows with the exception of what's already being inspected inside to out. So we see that router 4 can telnet to 2. But 2 is not going to be able to telnet to 4 because there's no entry in the state table, which means this falls back to the outside to inside pairing. And in class default, it says drop the traffic. So next, let's look at our traceroute packets. Now, from router 4, we should be able to reach anyone on the outside network. And let's say we were to go as far as router 1, where we're trying to get traffic from 4 to 3, 3 to 2, 2 to 1, and then to return back. From router 4, if we were to telnet to 200.0.0.1, we can see there's nothing wrong with this flow because it is being inspected. However, if I were to trace route to router 1, even though the ICMP flows are being inspected, the issue is that the outbound flow is different than the return inbound flow. And it says here that the packets are being dropped. It doesn't tell us exactly what the packets are, just that they're being denied. Now, if we were to look at a detailed debug, like debug IP packet detail or debug IP packet dump, we would see those return packets coming in on the outside and then being denied. Now, if we look at the show policy map type inspect zone pair sessions, and specifically I'm looking for the inside to the outside. For the inside to the outside policy, it says that if the traffic is not in the inside to outside class, it's going to get dropped. So one thing I actually may want to change here is in the inside to outside class, likewise drop the traffic and log it. And again, the only reason we're doing this is for visibility of the config, to figure out exactly what holes do we need to poke in the firewall. Okay, router 3 says I'm dropping a UDP session. It came from router 4, it's trying to get to router 1. This is the outbound portion of the trace route. Now, even if I were to allow this packet out, the issue is that when it returns from the outside back in, the flow is going to be different. Because for a trace route, the outbound flow is UDP, the return inbound flow is an ICMP time exceeded and an ICMP port unreachable. So to fix this, I'm going to have to make two separate unidirectional exceptions with the pass keyword. Specifically, I'm going to have to match traffic that is going from in to out. And say if it is the UDP packets that are the trace route requests, I need to pass these. Now, I'm not going to send them through the inspection engine, because if I were to inspect them, the router would try to receive in the reverse direction, the mirror image of the reply. But the problem here is that with traceroute, the request and the response are two different protocols. So instead of inspecting it, I need to pass it. Then as I'm going the other direction, as I'm going from out to in, I need to say that if it is an ICMP time exceeded or TTL expired, or ICMP port unreachable, that likewise I need to pass this. So this is the case where you would want to use the pass option, that you have some sort of non-standard protocol that cannot be matched by the inspection engine, but you still need to manually allow it through. But again, the key here is that the pass is only one direction. If I pass the traffic inside out, it does not mean that the traffic is automatically passed on the outside back in. So now to make these changes, let's look at what's the current configuration of the policy. So on 3 again, let's say logging console at level 5. Then show run. Let's just look at the full policy. And you can see the syntax is starting to get pretty big, even though the overall logic of the policies here are pretty straightforward. So this is definitely one of those configurations that you probably want to do in Notepad or your text editor to try to keep a close eye on exactly what the flows are that we're trying to match. Okay, so I need the inside to outside traffic and the outside to inside traffic. So there's inside to outside. Then I have outside to inside. I already have the zone pairing set up, so I don't need to change that. What I now need to change is exactly what's matched in the policy that's going from in to out and from out back in. Essentially what I need to do is from in to out, I would need to have another class, we'll say class type inspect, that is going to be inside to outside exceptions. Inside to outside exceptions class. Where for this class, I'm going to pass the traffic. Where this is different than the other classes that we're doing inspections. And on the outside to inside, I'm going to do the same thing. What this is going to allow me to do is that if I want to make a change later that is doing another manual exception, the only thing I would now need to do is add the match to that particular class. And these classes are going to say match any, where I have now the inside to outside exceptions and the reverse direction, the outside to inside exceptions. And you can see, just looking at the config side by side in the text editor makes it a little bit clearer as to exactly what we're trying to do. Okay, so from these classes, I'm trying to match access lists. Match access group name inside to outside exceptions ACL. Where in the reverse direction, it is the opposite. This is the outside to inside exceptions ACL. Where now I have the actual access list, IP access list extended, inside to outside exceptions ACL, that says permit UDP any in the range of, and we can see this from router 3 what we're trying to match. It's somewhere in the 33,000 range. Now, we could match these ports exactly, but as kind of a fuzzy match here, let's just say anything that's from 33,000 to, let's say, 35,000. So that should account for any of my outbound traceroute requests. Now, on the reverse direction, the outside to inside, this is going to match ICMP any time exceeded and any port unreachable. Now, the additional thing that I have to account for when I actually apply this configuration is that I need to make sure in the policies that are these two down here, I need to make sure the order of these are correct. Because remember, just like the modular quality of service, these policies are processed in the top-down direction. So on router 3, let's see if it's going to take this syntax. Okay, so the syntax looks good, but let's look at the result of it. I need to make sure that this policy map that is saying pass, that this is happening before the class default, which is good. Now, I may actually want to reorder these where maybe the inside to outside exceptions goes before the inspection class. Really depends on if the matches overlap with to begin with. So let's try this out now. On router 4, let's do the trace route. And on 3, let's turn the logging back on. So logging console 7. And router 3 says that it is dropping outside to inside traffic based on class default. Now, it didn't match the inside to outside, so let's look at that one in the reverse direction. Let's say show run section outside to inside. Now, I have the outside to inside policy that says for outside to inside exceptions class, pass the traffic. Outside to inside exceptions class says match outside to inside exceptions ACL. Outside to inside exception ACL says permit the ICMP time exceeded in the port unreachable. So I actually should be allowing the traffic in. Most likely what it means is that I need to remove the firewall policy and then try to reapply it. So let's do this. Let's take this portion out, the zone pairing. then reapply this. Where now it's working. So again, when you're making changes to the firewall policies, and the same is going to be true with a lot of the IPsec configurations when we get to that, it's very sensitive to the order of operations. That typically with an IPsec config, if you make a change, you need to remove the crypto map and then reapply it. Or in the case of like a tunnel interface, we would need to remove the tunnel protection and then put it back, or shut the link down and bring it back up. Same is true here with the firewall policy. The only thing that changed from here to here is that I removed the policy and reapplied it. I didn't change any of the actual configuration. But we can see now when we look at the show policy map type inspect zone pair, I should see that for the inside to outside, there are matches on the exceptions class. So these 49 packets that were passed, these were the UDP packets going out. Then for the outside back inside, outside to inside, says for this exceptions class, 6 packets were passed. These were the ICMP time exceededs and the ICMP port unreachables. So we could see from the configuration, the final result of this is much more complicated from an implementation point of view when we compare it to the content-based access control, to the CBAC syntax. But again, the advantage is that it makes the configuration much more modular, and that if there are 3 or more zones, so inside, outside DMZ, or maybe inside 1, inside 2, outside 1, outside 2, it makes it much more manageable to control how is the traffic going to be processed when we go from inside to outside versus inside to DMZ or vice versa.